Our Docker guide, we're going to start out with the basics, and we're going to basically just get started with some very basic Docker usage and just basic Docker commands, cover all the stuff you'd need to do day-to-day tasks with Docker. We're not going to do anything somewhat advanced with this. We're not going to go too far with it, but we're going to go pretty ways. This will pretty much be like a part 1 video. And you'll see here I have this document open on this page. Then we'll put a link to this document in the description, and this video will actually end up being embedded on this page once we finish recording it. So this is our Docker guide or tutorial, and this shows the contents of what's in the guide right now. So we're going to cover like what is Docker. There's actually a link to the Docker cheat sheet, which is a separate document we're not going to really cover today. We cover like installing Docker. I'm not going to demo that today because our test box already has it installed, but I'm probably going to create a separate video for Docker installation. We cover we're going to cover the basics, container lifecycle, resources, limits, all this basic stuff, how to deal with images, the Docker registry, building images from Docker file, volumes and storage. We're going to cover basic networking, exposing ports, network creation, connecting, disconnecting, all of that stuff, everything up to right here where you see overlay networks. Now we're going to stop there. So this first video, part 1, is only going to cover this much, and we're going to stop before overlay networks. And we're going to create, so basically overlay networks, swarms, compose, Docker machine, all that will be in a separate video. So stay tuned for that. We will also be recording that video in the near future. But for now, the basics are basically going to be all of this stuff. I mean, I know in this outline we show the basics being this stuff right here, but for our part 1 basics video, we're going to cover a little bit more. We're going to cover everything to down here. Now, let's see what else. So today you might notice that we're actually using OS X as our, we're basically using a MacBook Pro as our dev machine. You could use whatever you like as a dev machine. We also oftentimes use a Linux workstation. We're not going to be actually running Docker on this Mac though. We're actually logged in remotely to we're logged into a Linux server right here called Fuzzy Fox 1. Just a random name we assigned to this temporary Linux server. We're logged in as root on this Linux server, and this is the server where the Docker Daemon actually runs. So we'll be creating all of our containers on here. So let's start out, just take a look at what we have. So probably the first command you'll learn with Docker is docker ps. So say docker ps, and we are running it by default. You'll need root permissions. You can grant permissions to run it as a regular user, but by default you're going to need root access, and that's what we're working with today. So yeah, granting access to a regular user would be that's kind of out of the scope of what we want to cover today. So anyways, start with docker ps, and you'll see there are no containers at all, or none running anyways. This will show running containers. ps-a will show all containers including stop containers, and there are none of those either. It will show the container ID, the image that the container is created from, the command that it runs, when it was created, its status, any ports that are exposed, and the actual name of the container. So the first thing we're going to do is run a hello world program. So let's give hello world a shot. So we're going to scroll down here. Let's see. Maybe we should probably, let's just jump right into hello world before we talk about what is Docker or any of that other stuff. And I'll come back and gloss over the installation, but we're going to do a separate video for that. Or yeah, most likely that's going to be a separate video. There's a slight chance I might just splice that into the beginning of this video, but we'll cross that bridge when we get to it. So here is hello world, just to give you an idea. So you say copy, paste, docker run hello world. So docker run is the command to run a container, and the parameter we pass to that is hello world. Now hello world is an image created by the guys from Docker, and and basically it's up on their on the Docker registry. So we're going to specify the image that we use to create the container. This isn't the actual name of the container. This is the name of the image that we're going to create the container from. Now the name will be a randomly assigned name. We can choose to assign our own name. We'll get to that. But let's just give this a shot. Now, unable to find it locally, it's going to pull the image down from the internet. So pulling it down from the Docker registry. Let's see how fast this goes, and that was pretty good. I'm actually tethering off of my phone right now, so I have a really slow internet connection, but it looks like it was able to pull down the image for that pretty quick. Now, any image you don't have, it's going to search the registry and try to pull it down if you don't have the image locally. So let's give this, let's take a look again. So Docker PS still shows nothing. So the reason for that is because it's stopped. So if we say Docker PS-A, we see this is our container. Container ID, image was hello world that we specified before. The command is hello. So I guess that would be a script or a program that's embedded into this container and created in 29 seconds ago, and it exited 27 seconds ago, so it ran for a couple seconds. No ports are exposed because it's just a hello world program, and the name is Flamboyant Booth. So they're generally assigned goofy names like that. You'll see a lot of those. Now, running this hello world program, you'll see says hello from Docker. So basically, pulled down the image, said hello from Docker, and gave you a basic hello world message, which is all fine and great. So we could also say Docker images. Now I have quite a few images actually pulled down that I've been using on this test system already, but let's take a look. So here we have a bunch of images we have. This shows the actual repository, which is, you could think of that as kind of like the project or whatever. And you could see you can see what they're tagged as. You can use this for versions. You can basically, it doesn't have to be a number or anything. You could make a tag whatever you want. You could tag it as the latest or as an actual version. The ID is just an ID to identify the image. So it says when it was created. Some of these I've had there for actually that's not when it was pulled down. That's when it was last updated. So when the image was created, whether it's not when it was placed on this machine, but when it was created. So like 14 months ago, I pulled this one down a few days ago, or actually Hello World I pulled down just about a minute ago, maybe 30 seconds ago, but it was created 14 months ago. Anyways, it'll tell you the size for each of them. This one is pretty small, which is why we were able to pull it down. If we were pulling down Ubuntu, you see this Ubuntu image, we're going to do a lot with that. And we have an Nginx image. Those would have taken a little bit longer. They would be fine on a wired internet connection, or on maybe even not too bad on a tethered connection. But I've hit my data limit cap, so I'm on a throttled tethered connection, so it's extra slow. So I feel pretty lucky that I was able to pull down the Hello World program, or the Hello World image. So yeah, it even works on an extremely slow internet connection. So let's see, where do we want to go from here? All right, so the one thing you probably noticed, well, that we did notice right away, is that Hello World is terminated. You might wonder why. We just started it and it instantly terminated. That's because it's just a quick Hello World program that runs, and when the program finishes, the container terminates or exits, which is what it's supposed to do. Now, if you were running a server like, say, Nginx or Apache or MySQL or whatever you're running, maybe some Python application, it's basically going to stay running constantly, and your container will stay up and running constantly. So we have this Ubuntu image, and this actually runs a shell, and it stays up and running constantly. So it will stay running, and you can connect to it. You can attach to the container and run things on the shell. So that's really what we want to do to be able to see what Docker can do, is to be able to actually log into the container and look at it. So that's going to be our next step. So before we jump into that, let's talk about what Docker is. So we've run Hello World, and the next thing, probably the next exciting thing to do is to run Ubuntu. But before we do that, let's just gloss over what Docker is, and Yeah, all right, so what Docker is, here's a little intro about it that I'm not going to read through. You can read it. I do recommend that you click on the link in the description and follow this guide yourself, but for the purpose of the video, let's just quick talk about what Docker is. So Docker is a system for containerization. Container is basically an isolated environment that behaves like a separate system. So yeah, you could think of it like kind of like a virtual machine, except that it doesn't require an entire copy of the operating system to be installed, which is pretty nice. Each container has much less overhead than a virtual machine, and it makes it easy to package and ship applications. So basically what this means, it takes the idea of a virtual machine and goes one step further. So rather than having to install an entire OS on every VM that you create, with a container, they all share the same copy, they all share the same OS, and basically all the same everything. It just creates an isolated environment and makes it look like a separate machine. So it's a totally isolated environment running on the same operating system. You could kind of treat it like a VM or like a lightweight VM, but it really isn't a VM at all. And they're meant to be ephemeral. So like you would start them up and kill them just as quickly or easily as you would start or stop a process. And they're actually meant to be treated more like processes than like virtual machines. Now, in a lot of our cases where I create lab environments, I'll actually set them up and treat them as though they were virtual machines and log into them, administer them, and things like that. You're not really meant to do that. You're meant to build them off of an image, have everything set up ahead of time, and not really log into them too much, but just stop and start them and recreate them on the fly. So it's recommended that you don't think of them as VMs or treat them as VMs, but a lot of people tend to want to do that when they start learning about containers, and sometimes it does make sense to do that if you're using them as a lab environment or to test things out. So that's just worth noting. Now, installing on, let's talk about installation. So installing Docker on Ubuntu. So there's an easy method and an elaborate method. So the easy method, if you're on Ubuntu, you can just say sudo apt install docker.io. And docker.io is Ubuntu's Docker package. So it's a version of Docker that's been packaged up by the Ubuntu team and put in their repository. And that works really great, except that it's it's not going to be the latest and greatest. It's going to be a little bit behind. It's probably completely fine for anything you need to do. So if you just want to learn Docker or use it, this is not a bad choice at all. Nothing wrong with it at all. Now, you might want a newer version of Docker. So recently, worth noting, they've split, so the Docker team themselves have split Docker into 3 packages. So you have Docker CE, which is Community Edition. CE is for Community Edition. So they have Docker CE, Docker CE CLI, and Docker, and then they have just containerd.io, and they don't have the letters CE in that anywhere, which is not sure why they decided to name it that way, but in any case, you get these 3 packages. You need all 3 of them installed, and that will give you Docker. And also worth noting, there also is Docker EE and Docker EE client, and I'm not sure if this containerd.io package is actually the same one. Maybe that's the reason they didn't name it with a CE, that it's just shared between the 2. I'm not sure if this would be a separate package that you get when you install Docker EE, but EE is Enterprise Edition, and that's their commercial edition of Docker. So there's that. So if you want the latest, and I wouldn't recommend getting this unless you have a really good reason and you need like enterprise support or whatever. If you don't, just get Community Edition. That's the way to go. So if you want the latest and greatest, you can get the version of Docker from Docker. That's a little bit more difficult on Ubuntu. Yeah, so and you can also install this on Windows. You can install it on Red Hat based systems. You can install it on Mac OS directly if you want. We're not covering that today. We're just covering Ubuntu. And we're not even covering that in the guide at the moment. We may add that as a separate set of instructions, but it's also not hard to do. So anyways, to install it, you'd say apt-get install and run all of this stuff here. And basically what we're doing is setting up a repository, and these are some things you need to set up before you can actually even set up your repository, just some prerequisites, and then you can curl this package down, or you can curl this key down from the Docker website. You just run curl, it'll pull it down, and you say, and pipe that into sudo apt-key add, and that will add the key for the repo. Then you run apt-key fingerprint, and then from there you will, and this is actually how I installed Docker on this machine here. This is the version I'm running, and I actually installed this both ways. I created two separate servers, and I tested it out this way and this way, but currently this is the version that I'm running now. So anyways, you're going to run apt-add repository, adding this repo, and then once you've added the repo, you can say apt install Docker, and then those three packages that we mentioned above. So that gets your Docker daemon installed. Now I've listed here, you can actually start and stop the Docker daemon. You have Docker D. This is the actual binary that you could technically launch it from this if you wanted to, but don't. I also mentioned I listed the upstart commands here in case you're running a system with upstart on it for whatever reason. I just felt like leaving those on there and not removing them from the guide. But currently, if you're running an even remotely current version of Ubuntu, or even a Red Hat based system, you're going to have systemd, which gives you the systemctl command, so you can start and stop the Docker daemon like this. Now, after installing Docker, it's going to be running by default, and it's going to be running as a service by default. You won't actually really have to stop and start it unless you're troubleshooting it or something along those lines. So you don't really even need to do that, but you should know how it works. So coming back to basic Docker usage, here we have, so we ran the Hello World program, which is great. And let's see here, when a container finishes running, blah, blah, blah. Yeah, we covered all of this. So we're gonna, before we cover these switches, we're gonna actually try running Ubuntu. Now, there are two ways you could run it. You could run it and pass bash, or you could run it without that. Now, the default command that it runs is just a shell anyways, so you could attach to it. So it's going to run a shell no matter what, whether you pass bash to it or not. Here you're passing it a command. You're basically saying docker run it, and let's cover these. So T will allocate a sudo tty, and I is interactive, so you can basically interact with the container. It gives you a shell basically. Basically keeping stdin open even when nothing's attached. Anyways, you can tell it to run bash, or if you don't tell it to run bash, it's going to run a shell anyways, which will be bash anyways. So both of these are equivalent. But when you run this will run the Docker container in the foreground. So you can go like this, docker run it Ubuntu bash. So we're running the Ubuntu image. So this runs a container, and now you see we're logged into the container by default. So we can say ps this is basically same stuff that we would see outside of the container. Not a whole lot to do in here, so you can exit out of this, and we've exited it. You can say docker ps-a, and you'll notice that this one exited too. That's because basically the shell was the main program, and when we exit out of the shell, it finishes. So the container terminates. It's done its job. So there's a way to get around that, which we'll get to, but let's try this out first. So we can say docker run -it Ubuntu. Notice we're not specifying bash here, and same deal. We're in the. This is basically, it gives us a terminal on the container. So exit out of that and run docker ps-a. You'll notice that this one also, and you notice the random names that get assigned to it. But these are all, the first one was Hello World, and then we have two Ubuntu image-based containers, all with random names. So from here, we want to see how we might create one that doesn't die when we exit out of it. So the next command we'll try is docker run -tid. So the new switch there being the D, which runs in detached mode, which means that you're not going to be placed in a shell by default, and it will be running in the background. So let's try that out. Let's say paste this in there. There we go. So now you'll notice we're not logged into it gave us the container ID, and it just brought us back to a shell on our server. So we can say docker ps-a, and you'll notice while most of these have exited, this one that just started is actually up for 13 seconds, and it's still up now. So festive Shockley, this container is up and running right now. So it's running in the background. It could be doing whatever job we wanted it to do. Right now it's just running a shell and just sitting there waiting for someone to connect to it. There are some examples of other things you could do, but let's try, before that, let's just attach to this. So we'll skip ahead a little bit. So we're going to run docker attach. Docker attach, and then we could specify the container ID or the name. We're going to go with the name for now. So paste the name in there, and this will attach to the container. And there we go. We have a shell on the container. So not a whole lot running on here except bash. Let's exit out of the container, and let's run a docker ps-a. And you'll notice that it did exit. All right. Let's see here. So now our festive Shockley has exited, even though, all right, so we had attached to it and now exited, even though it was running in detached mode. So now the reason for that was because I actually typed exit, which is not what you want to do if you want to keep it running. So let's give this another shot. Let's run another detached container. So docker ps-a, this one is up and running. So we're gonna attach to, this one's running in detached mode, so we're gonna attach docker attach priceless Banzi. So paste, attach to this. So here we are, only running bash, not much else. So now instead of typing exit, which would terminate basically the main program we're running is the shell, and so if we hit exit, that's going to terminate the shell and thus terminate the container, and that's not what we want to do. We want to actually try to get out of here. So we see how docker attach will say connect to it, and then basically logs in. You can exit with a control P, control Q. So type control P, control Q in order. You don't it's not control P and Q all at once. You first press control P and then let go, and then you press control Q and let go. And it reads the escape sequence and exits out of the container. Now run docker ps-a, and you'll notice that priceless Banzi is still running. It's still up and running, so we could connect back to it again. So attach. Now say if we want to get out again, control P, control Q, and still running even now. So another way to connect to it is to exec a shell on it. So docker exec -it, and we're going to say basically our container name, which I should still probably have copied, and paste that in. And we actually need to specify a command to run. So we want to tell it to run bash. So we can exec, this is an alternate way of connecting to it. And now when we run psef, we can see there are two, see this first bash process is what runs by default when you created the container. And notice up here, that's the same bash when we had connected before, when we just attached. It's running bin bash as PID1, and running the psef command was PID10. So exiting out of this would kill it. So exiting out of this shell that's PID1 would kill the container, but note right now I have two bash processes. One is PID1 and one is PID12. So the one is PID12 is what I'm actually using. This is the bash prompt that I'm at now. This is the shell I'm currently logged into is PID12. So if we type exit, it will exit out of the container, but it should still be running. So let's take a look. And there we go, it's still running. It's been up for 2 minutes. It's still up and running, which is great. You could exec another bash shell on it, and see it still has my bash history now from the last time I logged into it. So PSEF, and you'll note that we have another, so we see PID1 is still running, which keeps the container running. That's the main command, and 22, our bash shell that we're logged into now is PID22, and the one we were in last time was PID12. So we killed the bash running as PID12, and we now have PID22. All right, so that's so there's another way to connect to it. I like being able to type exit and get out, but it's a little bit more typing to say docker exec it and then bash rather than just saying docker attach. But I really prefer to be able to SSH into things. You're not really meant to do that. I mean, it's kind of making it more of you're making your container more of a heavyweight thing to do. When I set up a lab environment on a container, I'm generally going to install SSH on the container, and I'm going to install whatever apps I'm going to run on it. But you really shouldn't be installing SSH because it just makes it more of a heavyweight thing, and you're not really supposed to have it on there. So it's not really the right way to use a container. I wouldn't recommend doing it in prod or creating your apps that way. But if you're just creating a test environment, by all means install SSH on there. These won't have SSH on them by default. They're really, really stripped down environments, so they don't have a whole lot on them. So anyways, let's cover a little bit more of this. So we have we've run Ubuntu. So we did docker run -tid Ubuntu running a detached mode Ubuntu container. So right now let's look at the difference between the run command and the create command. So if you use the create command, you're going to create a container without actually running it. So you'll notice we do. You're not going to put it in detached mode because it's not even running. So passing a D to it would be an invalid option. But let's give this a shot. So paste this in here, and let's take a look at what we have running. All right, so we see this new one, Boring Stonebreaker, is created, but it's never run at all. So we could start this, docker start, copy, paste this in, and now if we do a docker ps, we see it's running and it is detached. So we created it and we started it up. So we don't have to run it in detached mode if we just start something that we created with a separate command like that. So we can actually stop it too. So stop it, and we can see here it says exited 1 second ago, so it stopped. Now we can start it again. Here we go. And now if we check this, and it says it's up and running again. So we can stop and start containers. What else? We can also name our containers if you want. Let's say we want to call it my container 1. Copy this, paste it in here, and there we go. So my container 1. So we can instead of having these goofy names, we can just say call it my container 1, or we could just give it a different goofy name if we feel like it. Yeah, anyway, the big takeaway from all of this stuff up here, or one of the takeaways, is the difference between the run and the create command. So run will create and run a container, whereas create just creates it, and you'll have to start it or start it separately, and any container can be stopped. Let's see. Now, rather than just naming a container, we could specify a host name too. Now, this host name will allow it to be accessible from other containers on the same network. So it basically does, it gives you host resolution on the local network. So if you had, if you wanted to say connect to a database, say you had two containers, one is running a web server and one's running a database, and you wanted the web server to connect to the database, you could name the database server database, and you could just call it by name over the network rather than using the IP address, which is kind of nice. But we're going to call this one, the host name is test1 and the name is test1, and that's how you do it. So we're not going to connect those right now. We'll deal with connecting to them later on in either further on in this tutorial or in another separate video. We do have a lot of examples of how you would do that. I did that one in our Docker Hadoop lab. We have another we have another page on our site where we created a Hadoop cluster using Docker, and we installed SSH, and we named all of our hosts and specified IP addresses for them so that they could all talk to each other and do whatever they needed to do. So we have examples of that, but we're not going to show that example right now. We're going to cover a bunch of other stuff first. So we've already covered Docker PS and Docker PS-A. So you can actually filter out containers. You can say filter name equals, and then you could just show the container ID with a -Q if you want. So filter name equals Docker PS filter and you'll just show the one that you're filtering for. And if you say -Q, there you go, just the ID. Now this is actually useful. The -Q is useful for just grabbing the ID of a bunch of containers. So here we have, if you do a -Q, you can get a list of just the IDs for all containers, period. And that's great when you want to pass it to a Docker RM or a Docker kill, or rather a Docker stop, so you can stop all running containers and kill them all, which is a pretty nice thing to be able to do. Anyways, we'll get to that in a little bit. Now let's say if you want to look at information about your containers, you might say Docker inspect. So Docker, and in most instances where you could specify the name of a container, you can also specify the ID. So let's say Docker inspect my-container one. All right, so this gives us a lot of information. Let's see here. Scroll up to the there's a lot of stuff, but you can it shows you like the path. Shows you like its full ID, when it was created, blah blah blah. Some stuff about the image, a bunch of other things. The storage driver it's using, the host just a ton of information. Bunch of driver stuff, etc., etc. One of the more interesting things is, and it'll show you any volumes or storage mounted, but is the network settings. So from here you can see it has an IP address, or it has a gateway IP, and it should have an actual, so all right, so the network is, it has a bridge network defined by default. It's using the default bridge network, which we'll get to those coming up ahead. Has this gateway defined, this IP address defined, and a bunch of other network information it'll give you. So that's how you would find. You could grep that out, or there are other ways to just grab out the IP address or whatever else. Also gives you a MAC address right here. So that's all fine and great. That's how you would inspect a container. You can also do the same for images, which we'll get to, or not for. For networks anyways. I don't believe, you'll use different commands for images. So we've covered stopping and starting. What else? We've covered attaching, stopping. Now we can say Docker RM. So let's see, Docker PS-A, Docker RM, and say we want to remove this hello world container that we created before. There we go, it's gone. All right, so you can say we can copy files into a container. So you'd specify docker cp, junk, blah, blah, blah. And then you can say docker exec, and you can actually run whatever command you'd want. So before we actually, to connect to the container, we did docker exec bash, but you could, well, let's try both of these out. Docker, let's see. So I have a junk text file that says, I already have a text file here called junk. So we could say, we're going to want to say docker cp junk, and let's just copy this over to test1, and just in the root file system. Let's put this in var just to be interesting. And we might have, if we had an actual application or data directory, we might put it there. But let's give this a shot. Copy that in there. Now we could log into the container and verify that it's there, but here we're going to just use exec to verify that it's there. So we can say docker exec test1 ls lt. Yeah, let's do this in var. So we're going to just see what's in the var directory. And this will tell us what's in the var directory. Not a whole lot of stuff, but we can see our junk.txt file has been copied up there. So junk.txt. So you can run commands on your container. You basically can use exec to run whatever command you want on your container without actually logging into the container, which is pretty handy. And if you run a shell, it's going to give you a shell on the container like we did before. So right now, let's cat this out. So we're going to run cat and then the var junk.txt, and there we go. We catted out that file. You can rename a container if you want. Let's rename test1. Let's rename boring stonebreaker. Docker rename paste to smelly hippo, which is just another goofy name that we made up. So there we go. We've renamed it. Let's see here. Now we're gonna talk a little bit about container lifecycle stuff. So you can we've already talked about starting and stopping. Now you can stop two containers at once by just specifying two container names. You can restart a container by saying just saying restart like this. So yeah, nothing too exciting, but let's give this a shot. So it's going to stop and start it as you would expect, and there we go, stopped and restarted it. And we can see that's only up for 3 seconds because we restarted it. You could probably restart multiple containers if you wanted. Like this. And you can pause a container, which freezes it in place. So you can pause and unpause. You could wait for a container. So if you say docker wait in the container name, your command will just wait there until it's done. So if it's running like a job or something that's meant to terminate, you could wait for it to terminate in a script, which is useful, I guess. Let's try pausing. Docker pause test1, and let's see here. Test1 is paused, so it's up, but it's paused. Now you could say unpause, and it is now unpaused, so it's up and running like nothing happened. All All right, so we're going to try the docker wait command just to have reviewed it. So we're going to log out of this, and this is actually a VM. So SSHing to the local host and specifying this port will forward me over to my server. So we're going to try to log in on multiple terminals here. So grab this. And there we go. So we should log back on here also. And we're going to want to become root. Now, let's pick a container to test out here. So we can say docker wait test 1. And now this is just going to wait here. So you could put this in a script and have it wait at a certain place until it finishes running or doing whatever job it happens to be doing until the container actually stops. So let's see if I can, yep, not what I wanted there. Here we go. All right, so here's our other, we're going to say docker stop test 1. And there we go. Docker wait returned after I killed test 1, or after I stopped test 1. I didn't actually kill it. Which brings us on to the next command, docker kill. This behaves pretty close to the same thing as stop, except it doesn't send it a gentle signal to shut down. It actually sends it a sig kill, so it's faster than stop, but it doesn't give it a chance to close file handles and whatever else. It's just like it's just killing it. Let's run it just to have covered it. You know what? Let's start test 1. Start. And let's kill it. And there we go, exited. Interesting to note, the exit code, normally the exit code would be 0 when it exits normally. Here it's exit code 137. So we've covered removing contain. Yeah, I'm pretty sure we've covered. Let's run this anyways. Docker rm, right? Rm test 1, and now test 1 is gone forever, and unless we recreate it, which is pretty easy. You could run that for 2 containers. So we could say docker rm. Yeah, we actually pretty sure we did remove one already, but anyways, let's get rid of this guy. Be easier to just type this out. Paste this in here. And you can't remove them if they're running. So, I mean, you could force remove them, which is that? Yeah, we have a -F, so we can remove 2 by specifying 2 of them, and you can remove them, you can force remove them if they're running. You could either stop them or do a -F. Let's try -F. And there we go, now they should be gone. So we force removed them. And now to remove all containers running or stopped, this is a really handy command. You can say docker container rm -F to force, and then you just run in a separate little thing here. You can just run docker psa to get all of them, and q to just get the IDs. So give you a list of IDs, so you're removing a list of IDs forcefully. So let's give this a shot to get rid of the rest of the containers. And there we go, all gone. So nice and clean, we've removed everything. resource limits and controls. So Docker lets you limit resources and yeah, basically like your CPU memory and things like that on a per container basis. So this is actually going to be pretty important if you're running things in production. And we're going to cover this briefly here. We're not going to get into too much detail, but like let's say, for example, you want to limit your CPU. You could do a -c and like say 512 like this, which hold on. All right, so to limit, so you could limit your CPU usage to 50% on a container, basically by setting the CPU shares. So docker run -tid and do a -c and specify the CPU shares. So the 50% of the CPU shares is actually 512. So that would be like 1024 for 100%, and that's the number that they chose for that. Say docker run, basically say CPU set -CPUs, and then you specify the actual CPUs you want to use. So this will peg it to these specific CPUs. So you can tell it to only use CPU 0, 4, and 6. So it'll use those either CPUs or cores, whatever they may be. It's basically just pegged to those. So if you were to specify this, it wouldn't be able to use, say, for example, CPU 1, 2, or 3, or CPU 5, or anything. It can only use CPU 0, 4, and 6, or whatever you specify. And you can limit memory to basically by using a -m 300. Like in this example, it's 300 megs, so you could limit it to 300 megs. You can also specify storage options. Basically, in this example, we're just setting the size to 120 gigs, so we're not going to go above the 120 gig limit. And of note, this was not available on AUFS, but should be available on other storage drivers. There are a lot of other options and different ways of specifying things, so if you really want to see everything, like if you were really playing around with this and setting it up the right way in prod, you'd want to look over an actual reference and see every single flag and every single way of specifying everything. You'd probably want to test things out a lot in dev before going to production. But anyways, yeah, this is just the basics, just to give you an idea of how it works and to know what there is that you can do, not to cover every single flag and everything else. You're going to want to go into a lot more depth if you want to try this out in production. So you'll note over here, so what I did here was I ran, let me run this again, actually. So clear. All right, I'm gonna run a basically container with 512 CPU shares, and I had just created one, but here we go. And then say Docker, and we're gonna inspect that one. Docker inspect, and just grab this ID. I guess we could grab it by name too. Paste that in there, and you see all the details about it. Now we're just going to grep for 512 because that's the value we specified, and we know it's something we can grep by. So there we go, CPU shares. So that's a quick way to verify that we did give it 512 CPU shares. Docker ps-a, and we see I actually created 2 containers. I had created one off camera just a little bit ago, just to get this example ready. But this one, and you can call them by container ID or by the actual name. So the one that we had, and these container IDs are like the short ID. So for example, this one ends in 9067. This is 90. So this is the last however many characters of the long ID. So the long ID looks like this. The short version is just the end of it right here, and you can specify it by this shorter version or the longer version, whichever. So once you create the container, it basically returns this ID. So you can just copy paste it. It really doesn't matter. But anyways, there we go. 512 CPU shares. So let's try creating another one and limit it to CPU set. Now I'm going to use this exact example we see right here. and it's going to fail because I'm running it on a VM with only a single CPU. And I'm not going to create another VM for this, but let's say if we were on a multi-core system or a multi-CPU system with at least this many cores, it would work just fine. So run this and it fails. So requested CPUs are not available because yeah, out of all of these, only 0 is available because I've only allocated 1 core to this VM. I probably should try it with more, and I'll probably go into more depth in a later video, not in this one, in terms of resources and resource allocation and control. So that would probably be the place where I'll play around with cores and things like that. But within this guide, we're not going to go a whole lot deeper. But I will show how this can be set up successfully. So we can peg it to this one CPU, which I guess is not any different than the default in this case. But let's take a look. We're gonna want to docker inspect. We can just grab this, paste it in there, and grep for CPU. And let's see here, we set CPU set. Yeah, CPU, here it is, CPU set CPUs. And it only tells you 0, which is, it's hard to pick out from these others unless you pay attention to what you're looking at, because everything's set to 0 here. But in any case, yeah, you could, I guess we could just grep for CPU set. That would probably be the easier thing. CPU set, and yep. And obviously we're not looking at memory, we're looking at CPUs. Anyways, there you have it. You can look at the CPUs that you've pegged it to. That's basically how you would do it if you wanted to do that anywhere. Let's see. Let's try memory. Let's limit memory. We're gonna fire up a new container and limit its memory to 300 megs, just like in the example. And your kernel does not support swap limit capabilities, or the C group is not mounted memory limited without swap. That should be fine. Now let's docker inspect this. And there we go, we see something. I believe this is, let's say, docker ps-a. Let's compare that just so we can see what's going on. So docker inspect, we can inspect by name. So this most recent one, E6 over here. So that's going to, you know, I'm actually not, yeah, I probably pasted that wrong. Or not. Let's see here. Docker. All right, so let's check one of these older containers that we created and see if we see something similar. All right, so this is exactly what we're looking for. So if we look here, so this older, if you look on this list, the oldest container I created today, ID ending in 95 is this guy right here. And you'll notice memory is 0, so it has no limit on how much memory it can use up. So it could eat up all our memory if we want. Now we'll see here, we had specified 300 megs and we couldn't grep it out because it doesn't come out, it's not really specifying it in megs, it's specifying it in bytes. So you have bytes, K, and then megs. So it doesn't work out to be exactly 300. It's more like 314 and change. So you'll see these last two containers I created right here. There's a memory limit right there. So that's 300 megs. So each of these are limited to 300 megs. What else? So yeah, I had the IDs mixed up before. And yeah, that's actually kind of strange. I'm not sure why it's doing that, but this ID that it returned after creating this, after it says memory limited without swap, which is all, I guess it's warning me that I'm limiting the memory when there's no swap, which is fine, but I'm not sure why it's giving me this ID. That's a little bit strange. I'm actually not sure the reason behind that offhand. But yeah, there's no, I don't see that ID here unless I'm just completely missing something. But Docker inspect, copy, paste. Yeah, let's just take a look just to see. Yeah, this is festive. Yeah. Yeah, that's the most recent one I create. So I can look it up by ID. I can inspect by ID, and that is the correct. I'm not sure why it's not matching. Oh, yeah, funny thing, this is actually matching the beginning of the ID right here, which is interesting. I could have sworn it was taking that from the end, but I guess not. Anyways, yeah, I was looking at that the wrong way. So this ID, starting with AD77EBEF, etc., is right here. AB, blah, 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 blah. So that is the correct ID. I did have the correct ID. All right. Any case. I'd actually like to launch another one right here. Controls. And yeah, that's fine, I guess. All right, yeah, so I was just looking at that wrong. All right, so moving along here, let's limit one. Let's try limiting the storage. So I'm gonna run this example, but I'm not gonna run it as it's, you know what? I am gonna run it as it is here. You could run this or create it. I'm gonna create it. So create. All right, response from storage opt is supported only for overlay over XFS with P quota mount option. All right, so looks like this is not going to work with our current storage driver. So limit storage not on AUFS. I'm pretty sure I'm not on AUFS. In fact, let's take a look at our. This is kind of getting ahead. We're going to cover storage a little bit later, but not in like a huge amount of detail. But let's take a quick look here. So we can change our storage driver, but let's take a look. Copy this. paste it in here. All right, let's look for store. All right, so looks like I'm using overlay 2, which is kind of strange. So it's telling me error response from Daemon, storage opt is supported only for overlay over XFS with peak quote. Yeah, so I guess I don't have the peak quota mount option, and I'm not sure that I'm pretty sure it's not over XFS. I think that overlay over XFS would, like, I know I'm running overlay 2, which I imagine would have the same options and more as overlay, and but I'm pretty sure it's not over XFS. I mean, that's certainly not, if that's referring to my underlying file system, I'm running extension 4, so I'm pretty sure this is just not something that's going to work on the VM that I'm using today. So we're not going to be, so this one has failed for today. We're not going to be able to demo this, which is fine. Just, I guess it's still a good example to be aware of what we can't do. And that's, yeah, this is our brief section on resource limits and controls. That's all we're going to go over with that today. We'll dive deeper into that later, so we'll probably try all sorts of different options later on, but not in this lesson, not in this video today. So let's move on to stats, Docker container stats, logs, and events. So first thing you could do is Docker stats. So clear Docker stats, and this will give us some information about all of our running containers. So you can see the name of the container ID, the CPU percentage. So they're all not very busy at all. You can see the memory they're using it up, which is not a whole lot, but it is some. We can see the memory limits. Now this is interesting. So this VM that I'm running these containers on, has about 4 gigs of RAM. So we're seeing almost that much RAM as the limit. Now we see the 2 containers that I limited to 300 a little bit ago. Those are 300 right here, where the others are using like almost the whole 4 gigs. We can see network I/O. Looks like there is a little bit of network I/O going on for whatever reason. We can see block I/O, which is basically nothing. It's not reading the file system at all. And that's basically what that gives you. So let's take a look at Docker stats. You can specify a container. So Docker stats, and say we want to specify this guy right here, and we can see, should show us the exact same thing but limited by container, which is useful, or can be useful. Now another excellent command to get statistics about what's going on is docker top and then the container name. So this is not an actual container that exists right now, so this is just a random name that was generated when I put this guide together. So shows the processes in the container. So this command will show what processes are in a specific container. So docker top, and we're going to paste this container name in, the name of an existing container that's currently running on our machine. Let's run this, and this shows it's basically like running, it's not really like running top where it continuously runs. It's not like the Unix command top. It's more like running PS or PSEF on the container itself. So it's almost like it logs into the container and checks what processes are there, but it doesn't really log in. But we see bin bash. That's the only thing running on there. This is a way to inspect what's running on your container without going into your container. And what else? So Docker logs, so we can see the logs for that container. Docker logs, and paste this guy here. Paste that in, and not a whole lot to look at. So unfortunately, we don't have a much more interesting example. Let me see if I could maybe come up with something better. I have a couple more terminals. Yeah, so I have another terminal here. So maybe I could generate some actual traffic or some actual log events or whatever. So docker detach Um, this guy right here. Let's see if we see any log information now. All right. So not sure why that's in the logs, but it's showing up in the logs. So let's try to do some. You know what this is? This is showing us what's happening on the terminal itself, or on the default console. So it's like std out, or I guess everything is being printed out. So this is like the console is what we're seeing. So whatever I'm seeing, like say if I say, so this is not SSH'd into the container, but this is just connecting to its default terminal. So I guess everything, any logging or whatever else, this is the logging that it's referring to. So anything we see here is like say we say PSEF. Now we can check Docker logs, and we see all the output of everything that's going on there. So anything that was running in the foreground on this container would be shown there too. So let's try something like this. All right, let's see what this shows if we say Docker logs. It's showing us, I don't think this is going to be in real time like it is here, not that they're, and it's not, but, or is it? Is that actually up? Yeah, anyways, it doesn't matter. We can say something like this, and then check Docker logs again, and we'll see basically the same output. So yeah, nothing too crazy exciting. If you were running an application in the foreground here, you could leave it running in the foreground, and yeah, you can escape. You could leave something running in the foreground, writing to the foreground, like a daemon or whatever, and you could view the logs here. Probably you wouldn't do that, but you could. Anyway, so that's an interesting thing to play around with. Let's take a look at Docker events. So this is a little different from Docker logs. This will just show what events are going on with the container you want to look at. So let's grab the container name and this guy right here. Scroll down, paste it in right here, and I should pay better attention. You don't. This is for everything, so I did not need to specify a container name. So don't do what I just did. Anyways, I can attach to this container from this other terminal over here, and you'll notice it lists out some events. So container attached to this container right here. So it's basically telling you that someone attached to it and resized. I don't know why it's telling me that it was resized, but yeah, there it is. So I could, let's say if I exit out of this, I want to see what it tells me. So exit, and there we go, network disconnect. So the container died and it disconnected from the network. So that's when you shut a container down. I was on the main terminal for the main, basically connected to the main process, which is bash. And so instead of hitting Control P, Control Q, like we talked about earlier, I just exited out, and that caused the container to come down, and we see the events for that. What else could we do? We could say Docker run -td. Let's say if we let's add a few spaces here just so we can see the output being separate. And let's launch a container. And now we see on Docker events, container create. So a container was created. Did a network connect. So it connected it to a network by default. It connected it to, so the default network is the bridge network. We'll get to networks and bridge networks later. And the type of network is, unsurprisingly, bridge. So bridge basically just connects you to, it basically bridges you to the network that you're running Docker on. And usually it's going to be on a different subnet though. But it's different from being NATed, so it's not really NATed, but it's a bridge network, and you could actually route to it if you set routes up. which is kind of interesting. So I guess that gives you a basic idea of what we'd use this command for. So we can get out of here. So that's what Docker events does if you want to view Docker events. Let's see here, Docker port. So you can see Docker ports. This will show you what the public-facing ports of a container are. So this is not going to be interesting unless there are public-facing ports. So Docker port, let's see, Docker ps-a, Docker port, and we're not going to see anything good here, but let's take a look at Ubuntu. Paste this in. All right, so no ports at all. So that's what you'd see if there are no ports. Now, Docker. Now we're actually going to want to start up Nginx, and this might show us. Well, let's take a look. We might have to put this off until we get to ports. So Docker run -t Nginx. We're going to fire up an Nginx container right here. So Docker ps-a, and we're going to say Docker and Docker port Quizzical Jones is our Nginx, our currently running Nginx, and nothing there too. So we actually cover this a little further on, but let's skip ahead a little bit, and we're going to get to this later, but we're going to talk about ports. So this is something we'll cover a little bit later, but let's say if we were to expose some ports. So yeah, container port and the host port. So we're going to run. We'll get to this in a little bit. We'll come back to this, but say if we want the port to be available. So Nginx runs on port 80. So if we want, so on the container, it's going to be listening on port 80, but it's not listening on that port on our machine that we're running Docker on. So if we want that port to be mapped over, we specify the mapping when we create the container. So we're gonna map it out to port 1234. So here we can create a new container for Nginx, and now let's take a look at the container name, and let's say Docker port, and we're going to say copy this guy and paste it over here, and there we go. So it shows us right here, port 80 TCP is pointing to 0001234. So 00, these 4 zeros, these 4 octets of 0 refers to, that basically just means all IP addresses on the machine. So all the IP addresses on our Docker server are listening on port 1234. So if you were to access our Docker server on this port, it will basically point you over to port 80 on this container. So obviously you couldn't have 2 containers listening on this same port. You could have multiple Nginx servers all running on port 80, but they would have to map out to different ports. Like one could be 1234, one could be 1235, or however you want to do it. So anyways, that's that. Let's try wgetting it. Wget. Copy, paste, and looks like I didn't copy all of that. 1, 2, 3, 4. And there we go. Index cat index. There we go. It says welcome to Nginx. So this is the default Nginx page that we pulled down. Looks like it has a little style information in it, and yeah, so default Nginx page that we were able to pull down from our Docker container by accessing port 1234 on our local Docker server. So there you go. So that's all interesting and everything, but let's get back to where we were before. All right, so we were talking about right here, stats, logs, events, etc. And we talked about the Docker port command. So let's talk about Docker diff. So it shows changes to a container's file system. So if you look at Docker, let's just pick one to look at, Docker PS, and say Docker Docker diff. Let's run a Docker diff on suspicious Blackwell. So just paste this name in here and no differences. So we can say Docker attach and paste the same name in here. And there we go. So we're logged into there. And now let's say if we say echo testing over a file called test.txt, and then say echo testing over test2.txt. So we've written 2 files to the file system. Now let's say we write one more to, say, var temp. So there we go. And let's throw one in Etsy just to do it, just so we have a nice example. etc, and there we go. So now we come over here to this terminal and let's say run a Docker diff on suspicious Blackwell. And you'll notice there are a bunch of changes. So this file test2 has been added to the system. And var temp test2, Etsy test2, and just a regular test. So and it'll also show the directories those were put in. So anyways, that's a pretty good example of Docker diff. So when any operations you do that change the file system for your on your container will be shown in a Docker diff. Now if you were to commit these to an image, these would all be saved in the image, and then any container you create based on the image will have these changes. So there's that. And we're actually moving right along to images right now. So Docker images are containers are launched from pre-built images, and you can build and modify images yourself. You can also pull them down from Docker Hub or whatever registry you happen to have configured. So by default, Docker Hub will be the registry you're pulling images down from. They have all sorts of great things, like you've seen us pull down Nginx, Hello World, and Ubuntu images. So you can get images. I basically list them out here. You can pull them from Docker Hub, or you can commit your containers to an image, or you can build an image using a Docker file. So we've actually looked at this a little bit already, but let's take a look again. So Docker images will show a list of all the images we have. This shows the repository name, which is basically just the name of the image. Like we have Nginx, my image, Ubuntu, Hello World, and you could also specify that. You could specify the repository in terms of an organization and then an actual image name as the entire image name. Now you can tag them with a lot of times, like you'll just pull down the latest by default. So a lot of them are just tagged as latest. Some have no tag, some have no repository name. You could name them anything you want, like my update, or you could give them an actual version number. How whatever you want to do, it's just a string. And these will give you the image ID, just an ID to identify the image, tells you when it was created. So like Hello World was created 14 months ago, even though this VM didn't even exist 14 months ago. I hadn't pulled the image down 14 months. This is when it was created, not when I pulled the image down. And it shows you the size of the image. So like Hello World is really tiny, Ubuntu is a little bit bigger. They're all not too far off. See, Nginx is a little bit bigger than Ubuntu because it's probably about the same size image, but you add the Nginx server. Anyways, so you can say Docker history to see the history of an image. So say Docker history Ubuntu. Ubuntu. And this will show us what's been done to Ubuntu. So 2 weeks ago, I don't think these are. Anyways, these are some commands that have been run when building this image. So it looks like they've added a file, and I guess this is like the build process for the image. Let's take a look and see how Nginx is different. And you'll see, these are basically just the build steps to build the image. Runs command. Yeah, that's basically it. So anyways, moving along, you can remove images saying docker image rm. You can specify it. You can also remove by ID. You can specify the image name, or you could remove it by ID, remove it by name. So there's 3 different commands you can use to remove them. You can say docker image rm, docker image remove, or docker rmi. So all of those will remove images. What else? So if you want to remove all images, which you can basically say docker rmi, and you basically pass it the results to this subcommand where you run docker images-q, which will just list out all the IDs for your images, and pass those to the docker rmi command, which removes all those images associated with that list of IDs. So I'm not going to actually do this because I don't want to delete all my images and have to download them again. But let's take a look at what docker images-q does, and that just gives us a list of IDs. So yeah, there you go. So let's try removing these. Let's just remove a few that we don't care about. So we could say docker rm hello world. Let's remove hello world. We don't care about that, and it's so small we could pull it down easily. So paste that in there. Hello world. Oops. Yeah, and that docker image. There we go. So we've done docker image rm, and we could do docker image remove. So docker image remove. We can say paste this in here, and there we go. We removed another image. So list these out, and we'll note that those images are gone. So we've removed hello world and my image. So now we want to test docker rmi. So let's say we want to remove this guy right here. So let's remove test1, docker rmi. So we don't have to say docker, instead of saying docker image rm or docker image remove, we can say docker rmi. So it's like the shortest way to do it, basically. So we can just say test1, and it's gone. There we go. Test1 is gone. So that different ways to remove images. What else do we have here? We can create images from a container. So we could take any container you get, like this one. The funny name for the container was Smelly Hippo. So we could say we could not specify a repo name and just commit the image. We could specify a repo name if we want, like test1. We could specify we could specify a repo name like this, where we put like the organization name in here. We could also specify organization name, the name of our actual image, and put a colon and say the tag. This is how we would create a tagged release. So the colon my update is a tagged release, or is the tag for this release, just like the v123. So you'll notice over here I have a my update and a v123, and that's basically from running this exact command here. So let's give this. I want to actually delete these images and try recreating them again. So docker rmi, and I'm gonna try removing this and see if it removes all of them. And it didn't. So let's see what happens when I run it. No such image name. So when there's one that's not tagged, it gets rid of it. Or when it's latest, so that's latest would be the default, so it just deletes the latest. These others, I believe I will have to specify by tag. So v1.2.3, boom. And docker images. So So we were able to delete that, and now we can delete my update. We have to specify the tag. So my dash update, and now that's gone too. So docker ps dash a, and we haven't got, I don't think we've gotten to renaming yet, but docker rename, let's rename suspicious Blackwell to smelly hippo. Just so it matches, so there we go, smelly hippo, just so it matches what's in our documentation here, and we can just copy paste these commands. So this is what happens when we don't specify a repo name. So let's look at our image, docker images. So we see a few here. Now let's paste this in. So we're committing this everything that's in this container to a new image. We're building a new image from our container. So had we logged into our container and made a bunch of changes, we could then commit that to an image and be able to create as many containers as we want from it, which is a pretty handy thing to be able to do. It's not really the way to build images. You really want to build them from a Docker file. But if you wanted to, you could do some work on a container and then commit those to an image, which we're going to show you how to do now. It's still a handy thing to be able to do, and you should know how to do it. So anyways, Docker images. So you'll know up here we had one unnamed. It says none for repository and tag. And then we committed this without a name, without a repo name, and now we see two that are none. And let's see, before we had one ending in B9, so yeah, this latest one ending in AD, this is our new image that we created. Now, let's say we could name it if we want. This isn't terribly exciting because we can pretty well predict what it's going to do, but let's give it a shot. So Docker images, and there we go. It's named test1 for the repository, and tag is latest by default. So if you give it a repo name, it's going to give it a default tag. If you don't give it a repo name, it won't give you a default tag. So let's jump back over here and let's try naming it like this. Nothing special with this name, but let's give it a shot just so we can see how we came up with this. So there we go. This is a common way to name things if you're deploying things on Docker Hub. And let's do a tagged. There we go. We tagged it with my update, just like the previous image that we deleted. And now we're going to create another tagged release, or another tagged image, and we're going to call it version 123. So do Docker images, and there's version 123. All right, moving right along here, we actually have the ability to export, import, load, and save. So we can do a bunch of things to containers and images. So export will export a container to a tarball archive stream, and import so that exports a container. Now import will create an image from a tarball, excluding its history. So it just creates it in its current state, and you don't see the history of what's been done to it. So you could export a container and then import it as an image if you wanted to. So you could save it as a tarball, and you could distribute it on the internet or give it to people, put it on a file share and let your coworkers grab it or whatever. Whatever you might happen to want to do to it, and then you could import it as an image and then create new containers from that. Docker load will load an image from a tarball, similar to Docker import, except it includes the history. So that's going to be a larger image. So if you want a larger image but want to include the history, you can do that. Now Docker save will save an image to a tar archive stream, and it includes parent layers. So that's not saving a container, but saving an image. So let's give this a try. Let's when you do docker export my container, that's a stream that just goes to std out. So you want to pipe it to gzip and redirect it to this gzip file. So docker rename. Let's rename this container again. My container. There we go. And now let's try outputting this to a tar.gz file. And there we go, it's output. So there we go, tar.gz file. Let's just place this. Let's take a look at it just to see. So let's untar and ungzip it, and you'll notice it basically unzip. That's basically the entire file system of that of the of the container right there. So we did an export. We exported our container to a tar.gz file, and here we've tar.gz'd it, and we see the entire contents of the file system just expanded right here in this temporary directory that we unpacked it in. And we even see these files that we created, like test and test2. But we see everything. We see like the proc file system, the root file, all of this. Let's actually take a look at the proc file system. Proc and nothing there, which is fine, which is probably how it should be. That's just the special devices representing what processes are running and some other things. So, but you'll see like Etsy should have their stuff in Etsy. So you could edit these files and then repackage them up, and you could use this as a way to edit your container and do things to your container before repackaging it up and importing it again. So this is, you could probably build your own distro for a container this way if you wanted to. Anyways, let's remove that, and I should have kept, yeah, I do have my container because I just copied it in there. So let's try importing this. So let's say docker, so export, load an image, create an image. So we could load or we could import. Let's try both. So let's do import first. So we basically, docker import will take from std in, so you have to pipe data into it. So we basically cat out the gzipped file and pipe that straight into docker import. And you do a little dash to show that it's coming from std in and specify an image name. So let's try that. There we go, docker p images, and there we go. There's a my image, my tag. This is the thing we just imported. We just imported this image from that tarball file, which is pretty neat. That's pretty neat. You could actually export the file, do whatever you want to it, and then import it back in. So let's try loading it. So you could say docker load. I actually want to see how this works. Docker load my image. Did I? No, I'm gonna want to change the name on that. It's my container, but so I was not consistent in how I named these. But let's take a look. I mean, I guess I probably should call it my container or my image because it's. Anyways, here we go. Let's load this in. Docker import, no such file or directory. So I'm not sure why we're running into this issue, but looks like we're going to have some trouble importing that, or some trouble loading that. No big deal. You know what? Maybe load image from a. So maybe it can't load. Yeah, maybe it has to be an image. Let's try docker save just to see. So Maybe it can't save something that was a container that was saved to a tarball. That may be a limitation. So we're going to save an image to a tar.gz file. So maybe that naming is a little bit more appropriate. And it doesn't seem to want to do this either. Reference does not exist. Yeah, because there is no image with that name, which is fine. Let's pick an image that does exist. Let's just say Ubuntu. All right, so let's load this guy in. And there we go, success. All right, so it loaded it in as Ubuntu latest, which would just overwrite what we had there, which is fine though. All right, so anyways, that shows that we can, so export, import would go together. If you export something, you're not going to be able to use the load command to load it. You can save something and then load that in. So you can save an image and then load it back as an image, or you can export a container and then import it as an image. So that's an important distinction to make, and that should help you understand these commands. Anyways, great to play with, and we're going to move along to the Docker Hub /registry, which Docker Hub is the registry run by the guys from Docker themselves.